The short-faced bear wasn't just big, it was brutal. With a height taller than a grizzly, a speed faster than most predators, and an aggression to bully other predators off their kills, it dominated Ice Age North America. But with paleontologists now calling it the most violent bear to ever walk the continent, one question lingers. How did this apex beast rise, rule, and suddenly vanish? Fossils of the short-faced bear first appeared in the mid-1800s, pulling scientists into a debate over what kind of beast they had uncovered. Early naturalists found bones in caves and river deposits across North America, but confusion surrounded the remains because they shared traits with other bears that lived long ago. Some thought the bones belonged to extinct hyenas, while others connected them to giant versions of modern grizzlies. Eventually, experts realized they represented a new genus called Arctodus. The name Arctodus translates to bear tooth, hinting at the imposing jaws that set this creature apart. Two main species emerged: Arctodus simus, also called the giant short-faced bear, and Arctodus pristinus, known as the lesser short-faced bear. Each species showed strong build, but Arctodus simus took size to another level. Researchers placed these bears in the subfamily Tremarctini, a group including extinct lineages that once roamed the Americas. The push to classify these bears included studying their teeth, skulls, and limb bones. Paleontologists noticed that Arctodus bones had unusual proportions, especially around the face and legs. This combination of features made them stand out from typical ursine bears like black or brown bears. Scientists also discovered that Arctodus shared a distant link with today's spectacled bear, a smaller forest-dwelling species in South America. Yet Arctodus was far larger and specialized for life in open spaces. Arctodus simus in particular drew attention because of its massive size. Studies suggested it could reach weights of over 900 pounds in smaller adults, with some estimates exceeding 1,500 pounds or more for huge males. Fossilized long bones hinted at a towering frame that dwarfed many other predators of the Pleistocene. With forward-facing toes and a short snout, Arctodus simus looked nothing like the round-headed bears we know today. The story of Arctodus begins with the rise of bears in the Americas during the late Miocene and Pliocene epochs. An older group of bears, called Plionarctos, gave rise to the short-faced line known as Tremarctini. Over millions of years, shifting climates and evolving prey encouraged new body plans. Arctodus pristinus was the earliest form, smaller than its bigger cousin, Arctodus simus. Fossils of A. pristinus show it lived mostly in the eastern and southern parts of North America, while A. simus ended up spreading farther. Scientists believe that A. simus evolved specialized traits for hunting or scavenging in more open habitats. Glacial cycles created grasslands, shrublands, and patchy forests, forcing animals to move in search of food. Arctodus, with its long limbs, likely adapted to roam large distances. This allowed the bigger species to take advantage of prey movements or carcass locations across vast areas. Such an approach might have shaped its enormous frame, letting it dominate other predators when it found kills. DNA studies have linked Arctodus to the spectacled bear of South America, confirming that they share a subfamily. Though much smaller, the spectacled bear offers a peek at the short-faced line's genetic past. Some older theories proposed that Arctodus might connect to the giant panda or other unusual bear groups, but modern research points strongly to a separate American branch. The short-faced design, featuring deep jaws and robust limbs, stands out as a unique adaptation to the Ice Age environment. By the time the late Pleistocene arrived, Arctodus simus reigned as one of the biggest meat eaters on the continent. Saber-toothed cats and dire wolves also roamed the land, but Arctodus potentially outclassed them in size. Over many millennia, it refined traits that matched its active lifestyle. Its presence in both cooler northern regions and warmer southern areas showed how flexible it was. Even so, the fossil record remains patchy, making it tricky to track every step of its lineage's growth. The short-faced bear earned its name from a skull shape that appeared shorter and deeper than most bears we see today. Its snout gave it a unique profile, with broad cheekbones and large nasal openings. This design may have improved its sense of smell, letting it pick up scent trails over wide distances. The jaws were wide and powerful, hinting at a biting force capable of cracking bones or seizing big prey. In addition to the skull, Arctodus simus stood out for its height and limb proportions. Many reconstructions show a bear that could tower over a person when on its hind legs, possibly reaching 10 to 12 feet tall in peak individuals. On all fours, it might have been 5 feet at the shoulder. The front limbs were slightly longer than the back limbs, giving it a sloping back. This arrangement likely helped it pull down struggling animals or dig for food. The paws also had an unusual alignment. Unlike modern bears, which can have inward-facing toes, the short-faced bear had straighter toes that pointed forward. This stance could have made for a more efficient stride at moderate speeds. Some experts suggest it could gallop at a decent pace, though probably not as fast as a lighter predator like a lion. Still, for a bear that might weigh over 1,000 pounds, covering ground at any real speed was impressive. To support such mass, it had a sturdy skeleton. Large muscle attachments on the upper arms and shoulders signaled the ability to grapple. A thick chest, combined with a deep ribcage, left room for strong lungs and a robust heart. Some scientists think these traits reflect a lifestyle that involved roaming long distances to find kills or scavenge. If the bear needed to chase or displace other carnivores, having big muscles and endurance was a clear advantage. Teeth also offer clues to their versatility. The back molars were broad enough to grind some plant material, while the front teeth could slice through flesh. Wear patterns vary from site to site, suggesting different diets based on local habitats. Overall, the short-faced bear's body was a bundle of raw power, shaped by open environments and fierce competition. Everything about it, from its muzzle to its tall frame, spoke of an Ice Age giant always ready to push limits. For years, scientists wondered how a massive bear could move across the landscape without exhausting itself. Some proposed that Arctodus simus was built for swift travel, at least in short bursts. Its forward-facing toes and long limbs hint at a pace more efficient than you'd expect from a giant. Observers note that modern polar bears can still run over 25 miles an hour in short sprints, so perhaps Arctodus did something similar. When it walked, the bear's footprints likely differed from the pigeon-toed trackways of living bears. With straighter feet, it might have had a narrower gait, saving energy. A forward stance also helps with scanning distances in open terrain. Researchers look at leg proportions and muscle attachments to guess how it might trot or lope. A heavier body demands strong joints, so Arctodus probably avoided twisting motions, relying on forward power. This might explain the stable but imposing design of its skeleton. What about its daily life and social behavior? Some bears today gather in feeding spots or fish runs, but we lack proof of group living in Arctodus. It might have led a mostly solitary life, defending territories that stretched for miles. Larger males likely roamed widely in search of mates or carcasses to scavenge. Females may have used caves for birthing or shelter, but direct evidence is rare. We do find partial skeletons in caves, which might mean denning sites or accidental falls. Encounters with other Ice Age predators must have been dramatic. Saber-toothed cats lurked in brushy areas, while dire wolves traveled in packs. A towering bear could drive them off a kill through sheer intimidation, but if it faced a pack or a determined cat, fights were possible. Bite marks on some bones suggest Arctodus occasionally fed on large carcasses, though we cannot always tell if it made the kill. Its size alone puts it high on the list of most formidable mammals. Scientists have tested the nitrogen isotopes in short-faced bear bones to see how much meat it ate. These studies often show high levels of certain isotopes linked to carnivorous diets. However, the full picture is complex. Some samples suggest a near-carnivorous lifestyle, while others imply more flexibility. Arctodus had big canines for ripping flesh, but also broad molars that could handle some plant matter. This puzzle fuels debate on whether it hunted actively or relied on scavenging. One idea portrays Arctodus as a hyper-carnivorous beast that ran down prey. Others believe it was too bulky for long chases, so it might have stolen kills from saber-toothed cats or dire wolves. A third view sees it as an omnivore that ate meat when available and plants when times were tough. Its jaws and teeth do let it crack bone for marrow, which is a prize in scavenged carcasses. Some bear skeletons show little wear from chewing bones, so not all individuals did so often. Fossils from La Brea tar pits in California reveal that Arctodus did not show the same patterns of heavy bone crunching as hyenas or some extinct dogs. Instead, it might have been selective about which parts of a carcass it consumed. Meanwhile, in northern areas like Alaska, samples suggest a higher dependence on meat, likely caribou or muskox. This difference highlights the adaptability of Arctodus across its range. In warm climates, it could nibble on fruits or tubers when protein was scarce. If it did hunt, it probably targeted young or injured animals. A full-grown mammoth or bison would pose a threat even to a big bear, but smaller or weaker prey might be easier. Also, the bear's height meant it could stand upright to sniff the air for miles, helping it locate carrion. Some scientists think it followed migrating herds from a distance, waiting for a chance to scavenge. Others insist it had enough speed to ambush, though that remains uncertain. Arctodus simus ranged across much of North America, from Alaska down into Mexico and east to parts of the Atlantic coast. Fossils appear in states like California, Texas, and Florida, though they are far less common than those of smaller bears. This suggests it lived at low density, patrolling large territories. Many areas had open grasslands or lightly forested zones, perfect for an active traveler. Some remains show up in mountainous caves, implying they could handle varied climates. During the Pleistocene, glaciers advanced and retreated, carving new landscapes. Large herbivores like bison, horses, camels, and ground sloths roamed wide ranges in search of food. Arctodus followed them, whether to hunt or to take over kills left by other predators. Warmer stretches opened new paths, while colder periods pushed life south. Evidence from stable isotopes points to a reliance on C3 plants in many regions, meaning it dwelled around cooler woodland edges or open meadows lined with shrubs. In Beringia, the land bridge region covering Alaska and parts of Canada, some Arctodus remains show higher meat consumption. Sparse vegetation and harsh winters forced animals to rely on any protein sources they could get. The bear's ability to roam large distances might have been crucial in these settings. Elsewhere, like in Florida, conditions were more humid, with patchy swamps and forests. The bear's presence there shows it could adapt to different diets and habitats as long as large prey or carrion were available. Competitive interactions shaped its niche. Saber-toothed cats specialized in ambush, and dire wolves attacked in packs. Both had trouble defending kills from an enormous bear that could tower over them. American lions also prowled the plains, likely competing for the same bison or horse herds. Each predator found success in certain strategies, but Arctodus used size to tip the balance. Some trackways hint it moved methodically across open ground, scanning for a meal or for weaker animals to exploit. The presence of caves in some finds suggests denning or occasional shelter. Like modern bears, it might have used natural hollows for rest or raising cubs. We do not know if it hibernated. The biggest males might have stayed active, relying on stored fat to endure lean times. The sheer variety of fossils found in different environments underscores their adaptability. Though huge, it navigated everything from tundra edges to prairies. The giant silhouette of Arctodus cast a shadow that spanned a continent. Around 12,800 years ago, many large Ice Age beasts vanished, including Arctodus simus. The exact cause is not certain. Climate change reduced the big prey that sustained it. Human hunters also spread across the continent, possibly competing for the same animals. Less food and increased pressure may have spelled doom for a creature that needed massive amounts of calories. Some believe the bear's specialized size and lifestyle were no longer an advantage as habitats shrank and big herbivores dwindled. This extinction signaled the end of a predator that left deep marks in the fossil record. Museums often showcase skeletons of the short-faced bear standing on its hind legs, dwarfing viewers. These displays highlight how fearsome it must have looked. Artists paint it striding across ancient plains, a symbol of raw strength. Films and documentaries sometimes label it the most violent bear to capture public attention. The idea of a huge, swift killer bear resonates with our fascination for powerful apex predators. In local folklore, stories of giant cave bears might have persisted as legends. Some cultures revere large bears in their traditions, though direct proof linking them to Arctodus is scarce. Yet the mere possibility stirs the imagination. Bones found in caves can look fresh if well preserved, leading to myths about recent sightings. People across North America once lived beside mammoths, mastodons, and large carnivores, so the presence of a monstrous bear is not far-fetched in those ancient narratives. For researchers, the short-faced bear represents a prime example of how specialized forms can flourish during certain times, but become vulnerable when conditions shift. Its memory lingers in academic circles, fueling studies on predator-prey dynamics. Every new fragment of bone triggers fresh debates about its size or habits. The name violent sticks partly because the Pleistocene world was a fierce place, and a huge predator left behind awe-inspiring skeletons. Arctodus simus set a benchmark for what we call a super predator. Today, children and adults alike marvel at the scale and power of this prehistoric creature. It stands among icons of North American megafauna, along with dire wolves, saber-toothed cats, and giant ground sloths. School textbooks often mention it to illustrate the dramatic changes that ended the Ice Age. The big bear's legacy endures, reminding us that even the mightiest can fall to shifting habitats and growing competition. Arctodus simus earned its fearsome label, but nature still had the final say. researchers continue to probe the short-faced bear's past, seeking clarity on its true lifestyle. One big question is whether it sprinted after prey or mainly stole kills. Some scientists compare its limb proportions to faster bears like polar bears, noting that leaner body shapes can aid in bursts of speed. Others point out that a massive frame slows agility, making it better suited for intimidation or covering ground to find food. This clash of ideas keeps interest high. Genetic studies of rare Arctodus remains have opened new windows into its history. Mitochondrial DNA analysis revealed low genetic diversity, suggesting small populations vulnerable to environmental change. This might explain why it disappeared so quickly when the climate warmed and food sources grew scarce. Some remains from places like the Yukon show regional diets, while samples from Mexico hint at different local habits. Each new bone or tooth can yield clues about how these populations adapted. Tooth wear remains a popular topic. Some teeth look polished from gnawing on tough materials, while others show little damage. This mismatch might reflect different feeding styles or habitats. Those living near herds of big animals could afford to scavenge fresh kills, while others living in forest edges might nibble on more plant matter. Advances in stable isotope studies help pinpoint exact prey choices, linking Arctodus to bison, horses, or even smaller mammals. The range of possibilities continues to expand. Another debate focuses on how Arctodus used caves. Fossils in deep caverns might signal hibernation sites, maternal dens, or simple accidents where bears fell in. Some giant skeletons show advanced pathologies or injuries, raising questions about how these animals healed in the wild. Did they rely on large territories with multiple shelters? Did old males keep wandering year-round? We only get partial answers from the bones they left. The rest remains in the world of educated guesses. Arctodus simus, the towering, short-faced bear, lived in a world shaped by glaciers, vast herds, and raw survival. Its massive limbs, crushing jaws, earned it the label of the most violent bear to ever walk. Though it reigned for ages, changing climates and fierce competition spelled its end. Today we stand in wonder at its fossils, reminded that nature's balance can topple even the mightiest. In each bone, we see an Ice Age legend that still roars across time.